In this video, we're going to be looking at ACL concepts and how they are used as part of a network security policy. So we'll look at our various objectives here for Module 4, the purpose of ACLs, wildcard mask, your guidelines for creating your ACLs, and the types of ACLs. So why do we use an ACL, or how is an ACL used? Well, an ACL is the abbreviation for access control list. Now, access control lists are a series of commands used to filter packets based on the information that is found in the header of the packet. So by default, a router does not have an ACL listed. This is something that you would actually configure and you apply it to an interface. When you do that, the router is going to go through some additional steps to examine the information that's in that packet header and compare it to that set of commands that you have listed. There are several tasks that can be done or performed with an ACL. So you can use it to limit your network traffic. So if you want to block particular traffic, you can do that. Your traffic flow. You can provide a basic level of security on a network. You can do that by filtering, say, IP addresses, for example. You can do it by filtering your traffic type, so not allowing a particular type of traffic. So if you don't want somebody pinging a particular interface or to use Telnet, for example, you can create an ACL to prevent that from happening. You can also permit or deny specific hosts. Not only can you permit or deny the particular host, but you can filter that right down to the particular protocol that host is using. You can also do that for particular classes. You can help with your quality of service. So there's lots of different reasons to use an ACL. And in the real world, if you're looking at a router interface on a particular network, you might see pages of ACLs written. So these are still used. This is a real world type application that you're going to use and need to have knowledge and understanding of. So looking at your ACLs are going to operate at your network and transport layer, so layers 3 and 4. We're going to be looking at both standard and extended ACLs. Now, standard ACLs will operate at layer 3 only because they are looking at your IPv4 addresses, whereas extended ACLs will operate at layer 3 and 4 because you can add port layer or protocol information. One of the important concepts to understand with ACL operation is whether you're applying these to inbound traffic or outbound traffic. Now that sounds very simple, but when you start actually configuring these and thinking about your traffic flow, you have to apply these ACLs to the interface in an inbound or outbound direction. And that can become confusing when you're looking at the traffic flow as it goes throughout an organization. So it sounds really strange, but I do tell students to think of yourself as standing in the router. Think of yourself as the router and how the router sees the information. So if the traffic flow is moving towards the router, then that would be inbound. If it is moving away from the router, so as it's leaving the router, that would be an outbound ACL. So you have a packet tracer where you can look at ACL being demonstrated, so on how it's preventing a ping. So I would encourage you to do that. When you create ACLs, so we're looking in section 2 here. In section 2, we're looking at your wildcard mask. When you're creating an ACL, you permit or deny traffic, and you usually specify an IP address. When you do that, you also specify a wildcard mask. This works just like it did with OSPF, where you filter traffic, you match traffic based on ones and zeros using the wildcard mask. And remember that your wildcard mask is really the inverse of your subnet mask. So for example, if you have a wildcard mask of quad zeros, in binary that would be all zeros. That means you want every single bit within that octet to be matched. So remember the rules for matching ones and zeros. They're listed here. 0 means check and 1 means ignore. So if you want a particular bit position to match, you're going to use a 0. If you want to ignore it, you're going to use a 1. So let's look at the scenario of the 0.0.0.63. So what that would do would match the first 3 octets, and then in the last octet you would match the first 2 bits and ignore the last parts. So if you were to look at this in terms of a subnet mask, that would be 255.255.192, because the 128 and the 64 position are the 192. So you would want it to match the first 2 bits and then ignore the last 6. In this scenario, you have 0, 0, 0, 15. So you're going to match the first, the second, and the third octets, and then the 4 bits out of the last octet. So if you were looking at the subnet mask on that, it would be 255.255.255.240 would be the subnet mask there. So one way you can do this, if you're trying to figure out your wildcard mask and you struggle with that with your OSPF, is remember that it's the inverse of the subnet mask on that. So if all of these numbers were 1s all the way across for your subnet mask, they would be 0s for your wildcard mask. The other thing you could do is actually subtract. So if you subtracted what a regular mask is, which is the 255, 255, 255 for all 4 octets, then if you were to subtract this would give you your subnet mask. Subtract your wildcard mask from that. So that's the other way that you can do that. You can kind of look at this here. So they're trying to match 192, 168, 1.1. We want to filter this information. So in binary, this is what it looks like. 1, 1, and then you have zeros, and then second, third, and fourth octets. So if you wanted to match specifically to this address, you use the quad zeros. So 0, 0, 0, 0, and then what actually falls through is the 192, 168, 1.1, because you're matching it specifically. So let's look at a network address. So 192.168.1.1, we just want to filter what's in the network itself. So that means with a Class C address, you want to match 192.168 and the 1 in the third octet, but you don't really care what's in the fourth octet because you just want that entire network to match. So 0.0.0.255 would allow this network here, or deny it, depending on what you're writing. In this particular case, access list 10, permit 192.168.1.0, 0.0.0.255. So this is a syntax for configuring your ACLs. So access list 10, permit 192.168.1.0, 0.0.0.255. So let's look at this particular syntax here. Access list 10. Okay, access list is the first thing you would write. Now with a standard ACL only matches the source address. So to signify a standard ACL, this number after access list needs to be between 1 and 99. That signifies a standard ACL. So we have access list 10. It's in the 1 to 99 range, which means it's a standard ACL. And you either permit or deny the traffic. This is your address here, the 192.168.1.0 and the wildcard mask. So it tells the router which bits that you want to match or ignore. So in this one, okay, in this example, ACL 10 needs to permit all the hosts within this particular subnet. So we have the wildcard mask of 0015.255. So when you're looking at the 192.168.16.0 network, the mask is 0015.255. Why is that? Well, you want the 192 and you want the 168 to match, for sure. Now, in this last scenario here, if we're looking at the 16.0 network, you want the 16 to match. So you have 0000, and then you have the 16, and then the 8421. So 16 and 15. And then you're ignoring the fourth octet. Now, in order to know and understand what we're looking at here, you have to know your subnetting. So if you're struggling with your subnetting or didn't really learn that in your CCNA2, this is where it's really going to kind of show up, because you may struggle with this scenario. But if you'll remember from your subnetting, so that what they're looking at here is a 16 through 32, if you're talking about your subnetting. So you have an exercise here on practicing. I would recommend you do that. When I was referring earlier about subtracting your subnet mask, here's a good example of that. So if your starting value is 255, 255, 255, 255, and you're subtracting this subnet mask, so this is your given subnet mask, you have an address of the 192.168.3.0, and the subnet mask is a /24, which means 255, 255, 255.0. Subtract the whole thing from all 255s, and it gives you your mask of 000.255. Or if looking at it, you can tell that your wildcard mask is the inverse of your subnet mask. You can do that as well. So looking at example 2, you have 192.168.3.32/28. If you'll remember, your decimal equivalent of the /28 would be 255, 255, 255.240. So if you were to subtract that subnet mask from the original subnet mask of 255, 255, 255, 255, or the total subnet mask, then the result would be 0.0.0.15, which would make sense because a 240 is 1, 1, 1, 1, and then 4 zeros. So the opposite of that would be 0, 0, 0, 0, 1, 1, 1, 1, or 15. Now, there are some wildcard mask keywords that are important to know. One of those is host, and the other is any. So you can use the word host in the place of using the quad 0, so that it matches all the bits. The word any is a substitution for the 255, 255, 255, 255, or to ignore the whole address. So here's our syntax here for ACLs. Access list 10 permit 192.168.10.10. So if you want an exact match to that IP address, you could use the quad 0 or 0000. Or what you could do is down here, they said access list 10 permit host 192.168.10.10. So typing host 192.168.10.10 is the same as typing 192.168.10.10 and then the quad 0. This is just a little bit easier to type host in my opinion because it's less typing and you can make sure that it makes it a little bit easier to not have a typo there. With access list 11, we have permit, they're going to permit everything else. So permit zeros and then all 255s. So that means basically permit anything else other than this right here. And the other way you can write that is just put any. It's the same as typing all of this. Now, why do we have this here? So your ACLs, when you permit or deny traffic, by default, there will be an implicit deny all. So if you were to permit that traffic and then not permit anything else, you could deny all the other traffic. So you usually want to have a permit any statement, which says permit anything else to happen. The other thing you want to remember when you're creating ACLs is that you want to get very detailed first and then go broad. For example, if you have the 192.168.10.10 that you want to permit, but say you want to deny all the other traffic, you want to do your permit statement first to allow that one to go through and then deny all the other traffic. Because what if you did it the opposite? Well, your ACL reads it from the top down, so it would read the first statement. So if you denied all the traffic to the 10.0 network, it'll have denied it already before seeing the permit statement. So it's kind of too late. That would really be an issue if it were the opposite. Also, you could accidentally let traffic through that you didn't want to let through. And it's too late to go back and get it, kind of letting all the horses run out and then trying to retrieve the last one. So you also have some other rules when applying ACLs. Specifically, they're listed right here. A router interface can have one outbound ACL, IPv4 ACL, one inbound IPv4 ACL, one inbound IPv6 ACL, and one outbound. So you can have one each because they're two different protocols. So you can have one inbound and outbound each of an IPv4 and IPv6. Some of your best practices. Base your ACLs on the organization's security policies. So make sure that you don't violate any security policies. You want to write out what you're actually trying to do. So think about it from the router's point of view. When you're trying to apply these statements as to inbound and outbound, you want to create these in a text editor. Why do you want to do that? Well, you want to have these in a text editor. That way, if you need to change them, you can easily copy and paste those into your configuration instead of trying to do this on a live device. The other thing that you'll want to do is use the remark command. The remark command does not change the effect of the ACL, but if you have several pages, as I was referring to earlier, of ACLs, and you're trying to remember which one is access list 101, which one is 105, which one is 110, your remark statement will help you. It's just a little text statement that tells you this one is tied to a particular interface or has this particular functionality. And then you want to test your ACLs as well. So even corporations might use something similar to Packet Tracer, for example, to test out an ACL before actually implementing it on the network. Next, let's look at the different types of ACLs. There are two main types of access control lists. There's standard and extended. So a few minutes ago, I mentioned the standard ACLs. So again, the syntax is access list 10 permit 192.168.10.0 and the wildcard mask of 0.0.0.255. So what this does is state that we're going to permit traffic coming from 192.168.10.0 network, which is the network number. We're going to permit those hosts. In this next example, what we're looking at here is permitting traffic coming from this particular network going to any IPv4 address on the network using port 80. So access list 100, again, the numbers between 100 and 199 specify extended ACLs. Extended ACLs use source and destination addresses as well as port numbers. Whereas if you'll look at a standard ACL here, again, the numbers are between 1 and 99, and it permits a source address only. Here we have permit TCP protocol 192.168.10.0 network, its wildcard mask going to anywhere. You could have specified an IP address here, and that is equal to www, which is web traffic, or otherwise port 80. So you could specify the port number here as well. Numbered access lists are within the ranges that I was referring to earlier. So you specify the particular number. You can also do a named access control list. The named access control list helps you to be able to identify it a little bit better by looking at the name. So if you're trying to create an extended access control list that filters FTP, you could actually name that. So here we have permit TCP 192.168.10.0, the wildcard mask. So you're permitting TCP traffic from the 10.0 network to anywhere, and that is FTP only. The next one specifies the data for FTP. So one is the control information and one is the actual data when you're referring to your FTP. So you want to assign a name to identify the purpose of your access control list. They can contain alphanumeric characters. They cannot contain spaces or punctuation. It's suggested that you use capital letters. You don't have to, but it's suggested because they do stand out, so it makes it a little bit easier. And you can add and delete entries within your access control list as well. So we'll be looking at that, I believe, in the next module. So the other important concept is where to place your ACLs. I mentioned earlier that you need to think about whether traffic is going from inbound to outbound or vice versa. That's very important, and to kind of stand in your router or act like you're the router and looking at your information as to whether it's coming inbound or outbound. So here's our rules on where to place ACLs. Extended ACLs are usually placed near the source, whereas standard ACLs are placed near the destination. And if you're looking at that for the first time and reading it, it sounds very, very odd to say that. But let's look at this scenario. So we're going to use this scenario here. I'm going to scroll down. So we're going to block all the traffic from 192.168.10.0 network, which is this network right here. We want to block it specifically from going to the .30 network, which is right here. So this would be an extended ACL. And it's an extended ACL because we have a source and destination address. So if you're looking back up here, where extended ACLs are usually placed near the source. So an extended ACL, if we're trying to prevent this traffic, we would filter it here. And that would filter traffic and still allow it to go to the 192.168.31.0 network. And that's an extended ACL. Now, the reason that you might filter traffic if it's a standard ACL coming from here to here, it only looks at the source address. So if you had a standard ACL, notice it says they're placed near the destination. So I'm going to scroll back here. So what we would actually do is place that ACL right here outbound on R3. You could also, if you placed it here, that would prevent it from going to both networks. But if you placed it here, it would prevent it from going to this network. If you were to place an ACL here coming in to R3, you would apply it in. If you apply it to G000, since the traffic would be exiting R3, that would be applying it out. So if you're doing your extended ACL and you apply it over here, you would apply it from R1 as the traffic is exiting, so that would be out. So we're looking at that right here. So it's capturing all that traffic. So you just have to think in terms of where you want your ACLs and what type they are. Because if you were to apply an ACL to an interface in the wrong direction, it will not catch your traffic. Because when you look at your ACLs and you write your statements, that is only the first part. They don't work until you actually apply those to an interface itself. So we're going to try to look at one of those. Our next chapter or module is Module 5. This is where we're actually going to be configuring the ACLs, but I just wanted to give you a good example of that since we've been talking about it so you can understand the concept of trying to pull all this together. So let's look at this scenario here from Module 5. Now we have LANs 1 and 2. LAN 1 is 192.168.10.0 and LAN 2 is 192.168.11.0. Says assuming that only PC1 is allowed out to the internet, which is out here. So they wanted to write a standard ACL. So the first thing they've done here is write a remark statement. The remark statement, again, doesn't affect the functionality. It just tells you this access control list is going to permit only this host to get to the internet. So we have access list 10, which is between the 1 to 99 range. We're going to permit that host. So that's what they did in the first statement, and they did a show access list, which shows you that particular statement. So the next thing that they've listed here is access list 10 permit, and they're permitting 192.168.20.0. And your wildcard mask is 000.255 because they're permitting all the hosts in LAN 2 as well. Now, here comes the tricky part. So you've written the statements, but then you have to apply them. So if you're looking at this scenario and you want to filter your traffic, and we're going to go by the rule of your standard ACLs being closest to the destination, where are you going to apply it? So if it's closest to the destination, we would apply it here. And we're trying to capture traffic as it's exiting this router. So this should be an out statement. So if we were to look at that, interface serial 010, IP access group, because that groups these all together, the number was 10, and then out. Okay. So IP access group out. Now, what would have happened if you had applied that in? If you had applied that in, it would not catch the traffic because it's only looking for the traffic going outbound. Why couldn't you have applied this 192.168.10.0 right here? If you did that, because it's only looking at source traffic, it would not allow that traffic from 10.0 network to go to this network or here. So that's why you need to place your standard ACLs closer to the destination, because only filtering based off of the source address. So I hope that gives you a good understanding of your ACLs and how they're used, how the syntax is written. The wildcard mask are important to understand, and then again, how you apply these. So make sure you have a good understanding of Module 4 before we go to Module 5, and that we're actually writing the configuration for this, because you'll have to configure them. You'll need to modify them as well. And all this is very important for not only your module quizzes, but for preparation for your CCNA exam as well.